Good morning, AP Calculus students. It's Mr. Ford here from the home studio today. It's early in the morning, but sometimes you do your best work in the morning, I think. Today we're looking at topic F, special factorization from your summer packet. Factoring is again one of those things. I don't mean to use the word should too much or you had better be like a punishment person, but factoring is a thing that when you get to the kind of the pre-calc or the AP Calc level, a lot of times they just kind of expect you to know, oh, these things exist. I'm going to be real honest with you. I have never seen a perfect cube factorization happen on the actual AP test, although they are often used in assignments and such. And there are going to be a lot of these patterns that I do want you to be able to recognize. So in that spirit, we're going to go ahead and look at a couple of these problems and work them as best we can. Now, these first three are all going to require a pattern called the sum or difference of cubes. All of them are, if you're looking at 1, 2, and 3, all of them you can notice are something cubed minus or plus something else cubed. So this is what happens when I record in the home studio, that I often get this thing. It cuts out in the middle of my video. Shoot. It only takes a few seconds to get it back up, though, so this will just happen throughout this video, and we'll just deal with it as we go. See? We're back. Okay. Hopefully it doesn't happen too many times while we're here. Now, I'll be really honest, when it comes to sum and difference of cubes, I have to Google it every time. I've never actually memorized this one, so I'm just going to move this to the top, and you'll see what I'm talking about. I Google imaged this one here. Oh, this is the problem that we're working on right there. But right here, this is the pattern that we're going to need for these first three problems here. When you have, I'll be writing it on my notes with you as we see it there. When you have something cubed plus something else cubed, the pattern becomes you do A plus B times the first thing squared minus the first and second things multiplied together plus the second thing squared, like this. The same pattern holds when the sign is reversed to a subtraction sign. It's now A minus B, A squared plus AB, but this one is always plus B squared at the end there. So a couple simple patterns to memorize. It's actually not too tough to memorize it. I just have never gotten around to memorizing it, and I don't know, I like to joke that I do more math than anybody else a lot of times, at least high school math. Let's see, order, move to bottom. All right. Well, with that in mind, let's get to work on what we got to do in this problem here. So the key in these problems is always to identify what is the thing that is being cubed. So in this case, if you want to follow that same pattern we laid out, A is just x and B is the number 2, since 2 to the third power is 8. What you have here is you have x to the third plus 2 to the third. Might be better to think about it that way. So if we're following the formula, it'd be x plus 2 times x squared minus 2x plus 4. And that's all we would have to do there. That's it. It's factored. It's in its simplest form. Factoring is a thing that often leads you to easy solutions for problems and unlocks certain things that we couldn't otherwise do. So factoring is really important in pre-calc and AP Calc. It's one of those things you learn to do in Algebra 2, and if all you do is take Algebra 2, you're like, why did I learn how to do that? Number 2 is going to have pretty much the exact same answer as number 1. The only difference is that the order will be, or the subtraction will be changed. It's x minus 2 times x squared plus 2x plus 4. And if you think about expanding this out, you're going to have x to the third plus 2x squared plus 4x minus 2x squared minus 4x minus 8. And you'll see how it all shakes out. The 2x squareds cancel out, the 4x's cancel out, and you're left with x to the third minus 8. See how that works? It's pretty cool, actually. Now, number 3 is about as challenging as we can make these kind of problems. The puzzle here at the front is, what are the things that are being cubed to give us 27x cubed and 125y cubed? So you might be aware 27 is actually just 3 to the third power. So this is 3x to the third power minus, and then again, you might also be aware that 125 is 5 to the third power. 5 times 5 is 25. 25 times 5 is 125. So this is 5y to the third. So if you're following that formula, A is 3x, B is 5y, like that. Pretty rad. All right, now all we got to do is follow the formula. It'd be 3x minus 5y times our a squared, which in this case you got to really be careful here. A squared would be 9x squared plus, if we're following the formula, a times b, in this case would be 3x times 5y, which would be 15xy, and then plus 5y squared, so plus 25y squared. Looks complicated. It is. Also, I'm pretty quick to point out in the class is that things that are necessary for the actual AP test, things that are good to know as a calculus student, and things that are the kind of things that math teachers just throw at you sometimes. There's kind of tiers of things that are worth knowing. So this is low tier, if you ask me. But these next set of problems are high tier. These are ones we don't need a formula for, but it will require you to think about a problem a certain way. Now, in the past, you may have done things like maybe make a generic rectangle. This is certainly a thing we teach, like, my Algebra 1 students learn how to do this. The trick now would be to learn how to split up this 11x squared into these two boxes there so that it all shakes out. This is fine. If you want to do a method like this certainly does work. You could solve maybe a quick diamond problem where you need two numbers that add to 11x squared and multiply to negative 80x to the fourth, and then that would be how you fill up that boxes. You could use a slip and slide or some other thing. But I think I'm gonna erase this from my notes. I think the best way to solve this problem is to use kind of a little bit of an algebra trick. Let's just bring in like a capital A, and let's call capital A x squared. And what that does is it reframes the problem a little bit. X to the fourth becomes capital A squared because x squared squared is x to the fourth. And this is 11a minus 80. And now what you've got is you've got a quadratic equation that is factored into 2 bits. And the leading coefficient is just a squared. So this is a and a, like that. And now it's kind of the same puzzle with that diamond problem that I just laid out, is that what two numbers multiply to negative 80 but also add to 11. So at the end of the day, you're still solving the same diamond problem. What multiplies to negative 80 and adds to 11. And I'll be honest, I'd never had a better way of solving this other than just guessing and checking it. So let me stare at it for a minute until I think about it. 8 and 10? No. 5 and 16. That's it. 5 and 16 is 80, right? Because yeah, 5 times 16 is 80, and those are 11 apart from each other. So it would be 16 and negative 5 is what would have to go there. Yeah, so this would be a plus 16 minus 5, like that. And then, of course, what you would do is you would replace the a back with your original x squared plus 16 times x squared minus 5, like that. And so it might be worth distributing it all the way out and checking it, but these are the same expression, I think. Yeah, you'll get 16x squared minus 5x squared, which is the 11x squared, and you'll get x to the fourth in front, negative 80 in the back. We're going to do pretty much the same thing with this one. This is an interesting kind of factor game. If you are looking at the different parts, there's a lot of different ways to go about this particular problem right here. If you are looking at, let's say the first two chunks, the first two terms, you might ask yourself, what do those first two terms have in common? They have a c. They both do. So let's factor out a c, and that'll give us a plus d, like that. So as far as the first two terms go, we've kind of replaced them with an equivalent form. Now, I don't like this kind of problem because I feel like it's kind of special, and this method only works for this particular setup of a problem, but I mean, I suppose it's worth mentioning that you could do it this way. So, all right, next. So the next thing is we have this AB and this BD. Now they both have, first of all, they're both negative, and they both have a B in common. So let's factor out a negative B, and I think you'll see what happens right away is that you also have a plus D left over when you do that. And what's cool is that those are the same thing. So we can kind of do like a second tier factoring. Let me get rid of my highlight. because these terms both have an a plus d in them, we can factor out the a plus d. It's kind of weird, but so a plus d, oops, d I said, a plus d times c minus b is what happens. So we actually factored out a plus d from both those terms. So we undistribute it, and there you go. Now it's in factored form. And if you were to expand it, you'll notice that it does go right back to the original form that we have above. Only okay. So here's 6. 6 is a very similar problem to, well, I think this is actually kind of out of order. If you ask me, I think usually I want to put the minus 20xy in the middle, but this is kind of the same thing. So looking at this, let's think about it for a minute. This is I usually, when I do these answer guides for the class, I usually don't have an answer in front of me. I'm like genuinely thinking about the problem. So and the first thing I noticed is that there's a 2. Everything divides by 2 here, so I'm tempted to factor out that 2 right away, but I don't know if that would help very much. I do know, let's see, 20x squared. I think it is going to be a game kind of like number 4, where I'm going to need to split up the 20xy into both things. Yeah. Okay. Well, you know, I've got CPM on the brain. I'm doing Algebra 1 a lot lately. I want to try something here. I want to try a 2x squared up here and a 50y squared down there. And I think what we need is we need 2 numbers that, oh, maybe not. Maybe not. Scrap that idea. Well, I'm thinking about, right now, I'm kind of considering 20x squared minus 20xy plus 50y squared. That's kind of how I want. I'm just rearranging the problem in my head. And I'm thinking about how I can restructure that so that maybe in such a way that I can factor out something out of the, like I want to split up this mega minus 20xy into kind of 2 ideas. And I want to do that in such a way that I could factor out something x out of the first 2 and something y out of the second 2 and have the same thing left over when I was all done. It's kind of where I am right now. So now I'm thinking about what multiplies. Let me think about this for a minute. Can I kind of reframe this as a diamond problem, which I like diamond problems quite a bit. Is there anything that multiplies to 100x squared y squared that would then also add to negative 20xy? That's kind of what I'm thinking right now. Numbers that multiply to 100 would be, that are 20, that would combine to 20. They'd have to both be negative here. So 4 times 25, no. It's probably going to be somewhere towards the middle. 10 times 10? Oh yeah, 10 times 10. Oh, interesting. Minus 10, minus 10. So what about minus 10xy and 10xy? Yeah, that would do it. So, okay. This is kind of an old school method, but now that I've kind of cracked that code, how about 2x squared minus 10xy minus 10xy plus 50y squared? This is kind of I used to teach Algebra 2 this way years and years ago. I just want to point out that I just split up minus 20xy into two separate minus 10xy chunks. And now I kind of want to apply the same method that I used in number 5, because in these 2 terms, the first 2, I can factor out 2 and x. So I'm going to factor out 2x. And that would leave me with x minus 5y. And, watch this, like mathematical magic, out of the next 2 terms, I can factor out 10 and y. But I'm going to factor out a minus 10y, and I'll show you y in a minute. Because when I do that, what I've got is x minus 5y. Look at that, like magic. So this did end up kind of becoming one of those diamond problems that I was kind of thinking about before. It's really just a matter of how you split up that minus 20xy to get it to factor nicely. Because now we can use the same kind of thing we did back in number 5. We can actually factor out x minus 5y from both of these terms, which leaves us with 2x minus 10y, like that. Pretty rad. Hey, I think we did it. Cool. Okay, let's keep going. Look at 7 through 9 here. They're going to get a little crazy here looking at these problems, but, you know, what doesn't? We might require some other kind of crazier methods too, but I think a lot of these are going to rely on the same kind of things. So this first one, number 7, let's see. I'm looking down the line. I don't notice anything. There's nothing that everything has in common. If I factor out an x out of those two, it becomes x plus 12. But the other term has y in it, so I don't know. I don't think that's going to be a thing we can do. Let's see. 36 and 9 both have 4. And I'm just kind of looking for an attack point, like an entry point to this problem. 36 and 9 both divide by 9, but that would leave me with 4 minus y squared, which would be a difference of squares, but I keep thinking, I mean, it's possible that we might just have some sort of weird other answer here. I see. Okay, interesting. So take a look at these 3 right there. I think that's going to be the key to the problem. X squared plus 12x plus 36. I don't know if you recognize that or not, but this is what we in the hood call a perfect square trinomial. Meaning x squared plus 12x plus 36, that can be factored into x plus 6 squared. That's x plus 6 times x plus 6. So if we just ignore 9y squared for a minute and just factor that, what we'll get is x plus 6 times x plus 6 minus 9y squared. And we can write that now as x plus 6 squared minus 9y squared. Cool. And this actually creates a really common factoring scheme we haven't talked about yet, but it's probably the one that we expect you to know the most right now, and that is a difference of squares. A difference of squares is basically this pattern. If you have a squared minus b squared, it easily factors into a plus b times a minus b. Like the simplest factoring scheme there is. It's exactly what we're going to do here. In this case, our a is x plus 6, and our b is 3y. So that's exactly what we're going to do. This is going to be x plus 6 plus 3y times x plus 6 minus 3y. I think that'll work. I mean, it's going to be pretty tough to check, but we need to multiply everything together here. That's multiplying 3 by 3 is never fun. I mean, it would work though. Let's do it for fun. How about why not? We're here. We got the time. It's morning right now. We have x, 6, 3y. We have x, 6, negative 3y. We're going to have 3xy. We're going to have 6x. We're going to have x squared. We're going to have 6x. We're going to have 36. We're going to have 18y. We're going to have minus 9y squared. We're going to have minus 18y. And we're going to have minus 3xy. So let's look for opposites here. I got 3xy, negative 3xy. I got negative 18y, 18y. Look at that. We did it. There's your x squared. There's your 12x. There's your 36. There's your negative 19y squared. Cool. Pretty cool. All right. If you haven't learned this about me yet, I'm a huge dork when it comes to this kind of stuff. So, number 8. I love solving puzzles. It's like my favorite thing. Number 8. Let's see. I notice, let's see, almost every term has an x in it, except for the y to the 3rd power. Now this, unlike number 7, the x's and y's are all kind of mixed up in here. Well, you know, I'm reminded of my Algebra 2 days teaching general polynomial formulas. Something's going on here. I got an idea. It's gonna be kind of obscure. I'm not sure if it would occur to anybody puzzling over this. I'm not sure this would occur naturally, but that's kind of the nature of calculus and beyond. Is you look at puzzle solving strategies that would be like, I don't know if I would have thought that on my own, but once you see somebody else do it, you're like, oh, I can see how that makes sense. So I'm gonna just say for a minute, let's assume, I'm just taking a guess. Let's assume that x equals y, just for funsies. So what that gives us is x to the third minus x times x squared plus x squared times x minus x to the third. And, see, watch this. What happens? This ends up being x to the third minus x to the third plus x to the third minus x to the third. These both cancel out, and you're left with 0. So what that means, all right, so that's what I kind of was looking at. That I think if x and y are the same number, then this equals 0. That's a kind of a thing I noticed right away, because I saw the same kind of patterns developing in the same problem. So what that means, since I'm just going to kind of make a conclusion, since x equals y causes this thing to equal 0, this means that x minus y is a factor of this polynomial, because when x equals y, it causes the whole thing to be 0. So what we're going to do now, and I apologize for doing this in this video, in this assignment, I apologize for doing it this way. There's probably other ways to think about this problem, but what we're going to do is we're going to do long division, which we will talk about in chapter 1 of AP Calc. And what we're going to do is we're going to take x to the third minus xy squared plus x squared y minus y to the third, and we are going to divide it by x minus y, because I want to see what's left over. If I get rid of the x minus y factor, I want to see what's left. So I'm going to run through a polynomial long division. I did not expect to do that when I started recording this video, but there we are. So first of all, to get x to the third go away, I'm going to have to put an x squared here. X squared times x is x to the third. X squared times y is minus x squared y, which I suppose has to go over here underneath this factor. And when I subtract those, because we're subtracting a long division, these ones go away. I'm going to have I guess these are gonna combine together. I'm gonna have I'm gonna move them over here. 2x squared y minus xy squared minus y to the third. That's the next one I'm gonna get rid of. Okay. All right. What I did is I combined together these two guys, or not those two. These two, and I put them in the front this time, but everything else moved down. So now I need to cancel out 2x squared y by multiplying it by x. So I need a 2 and an x and a y. So plus 2xy goes in my answer up here. When I multiply that times x, it becomes 2x squared y right there. 2xy times negative y becomes minus 2xy squared. And now when we subtract to go to the next level, these guys go away. Negative xy squared minus negative 2xy squared, that's the same thing as adding 2, so it becomes positive 1. It's xy squared minus y to the third. And I think this will work, because if I need to cancel out the y, so I need a minus y in my answer up there. And that will give us, let's see, oh, no. I'm multiplying by x. I misunderstood. I need to multiply by plus y squared. That will do it, because y squared times x is the xy squared that I need. Okay, yeah. And then y squared times negative y is minus y to the third, and it all goes away. It's 0. There we go. So, jeez. All of that said, here's what our original factorization tells us. This is x minus y times x squared plus 2xy plus y squared up there. Pretty cool. There. I think that's done. I don't think I can factor x squared plus 2xy. times y squared. Or, well, no, we'll see, we can, though. One more thing. Again, this is, I don't want to, I'm trying to use the word should so much in these videos. I don't want anybody scared coming into this class. That is also a perfect square trinomial. That green highlighted thing there. That is x plus y squared. Kind of like we had another one up above in one of the other problems. But that is a perfect square trinomial. X plus y squared. There you go. This is the most final factorization for that. Number 9, thankfully, I think I see right away a strategy on this one. It's all about recognizing what things these guys have in common. With number 9, kind of the mathematical strategy that I want you guys to have looking at this problem is that there are only just 2 terms. This term can be thought about as a plus b. And we do this a lot in advanced mathematics. When you see a big, long expression with a lot of different things happening, if you can just think about it in terms of its simplest chunks, like a plus b or a times b or, I don't know, a over b, it gets a lot simpler when you just break it down into its chunks like that. So if we look at a on the left and b on the right, what do they have in common that we could potentially factor out? Well, they both have at least 2 x minus 3's. B has 3 of them, A has 2 of them. So let's factor out x minus 3 squared. That would be the greatest common factor when it comes to the x minus 3's. They also both have at least 2x plus 1's. B has 2 of them, A has 3 of them, but they both have at least 2. So they also have 2x plus 1 squared. So we are actually going to factor out that. We're going to factor x minus 3 squared times 2x plus 1 squared. That is the greatest common factor of this current expression. What's going to be left after we do that is, well, whatever divides out. Like, for example, for A, we've taken care of the x minus 3 squared, and we've got 2 of the 3 2x plus 1's, so we would have 1 2x plus 1 left over. Again, I'm just talking about A right now. A just requires 1 more of those. And B, similarly, B has 3 x minus 3's and 2 2x plus 1's. So 2x plus 1's are taken care of, but there's 1 more x minus 3, so plus x minus 3, like that. And I don't know. I think that's pretty much done. There's nothing really that we can do. I suppose we could simplify this expression. We can like combine like terms in that expression. So I think the factored version of this is x minus 3 squared times 2x plus 1 squared times 3x minus 2. Yeah, 2x plus x is 3x, and 1 minus 3 is 2. Hey, nice. We did it. Well, this one got a little away from me in that last problem number 8. I'm not intending for any of these videos to go over 25 minutes, but I got a little. Plus, it's early in the morning. I got my coffee. I'm in my studio. I'm relaxed. That's great. I'll be recording most of these since this is I'm recording this the Saturday after the last Friday of school, so there's exams left over. So I'll probably be recording the rest of these at home. So anyway, special factorization. Again, I'm gonna say at the top, my objective here is to keep you warm and ready for what's gonna come, to get you ready for the level of expectation in calculus, but also convince you can do this. You can do it. What one fool can do, so can another. You're hearing me say a lot of encouraging words. You are so capable of this, and I'm very proud of you for enrolling in the class and sticking with it. And just keep it up. Don't give up. You can do it. All right. You're great. Enjoy your summer. Hopefully, when you're watching this video, it's a bright, sunshiny day outside. And after you're done doing a little bit of math, you're going to go outside and enjoy being a person for a while. Maybe have a job. Maybe you're going to go wakeboarding or, I don't know, something cool that people do. So I will see you in the next video when we'll talk about linear functions. Ooh, that's a good one. Okay. Can't wait. See you in the next video.